So, remember exponential functions?
No.
Yeah.
No.
What is it? Y equals b to the x. It's written in exponential form. Alright, and we talked about inverses already. Alright, so remember with the inverse you switch the x and y, and this is good review for your final exam as well. Okay? Because you'll have a couple problems like that. But when we are finding the inverse of exponential functions, there's something called logarithmic functions. Alright, so make sure you put this title. And today's just an intro. In the next few days, we're going to go more in depth and practice this information. Alright, so make sure you get the title. Logarithmic functions. Alright, first thing I want you to write down about logs, and that's the short, that's what we call it for short, okay, is that it's the inverse of exponential functions. So the inverse of y equals b to the x. And it's just a different way to write exponential functions. All right, it's a different way to write it. That's what I want you guys to think about. It's a different way to write exponential functions. B to the x. All right, remember we were plugging in values for b? Okay, or sorry, plugging in values for x. All right, those were our exponents, and when we graphed it, it was either exponential growth or reflection of exponential growth, exponential decay. Well, now we're going to be looking at the inverse of that. It's the reflection over the line y equals x. You guys remember that? Does that sound familiar? Okay, so if I'm going to rewrite this, first it's important that you know what the base is. So in y equals b to the x, what is the base? B. All right, the exponent is the x. All right, and if you can remember that, then you can write this in logarithmic form because we have log, and listen to how I'm reading it, it's really important. Log base b of y equals x. And I heard my math teacher in high school say this over and over and over again. And one of my friends to this day, when she writes me a birthday note or a letter, she always says, because she thinks it's funny, I don't know why, a logarithm is an exponent. Okay? So if you look at this, a logarithm is the exponent. Equals is, right? A logarithm is the exponent. Here's my exponent. So that might help you remember that your exponent goes on the other side of the equal sign. Okay? All right, now here, if you remember with exponential functions, b had to be greater than what? Do you remember? It had to be greater than 1. Awesome, very good. Because remember, if it equaled 1, it would just give us a line. 1 raised to any power is just a line. So exponential functions, b had to be greater than 1. All right, that's going to be important here as well. So let's go through and try. We're going to try to go back and forth between these two, writing it from exponential form to logarithmic, and then back again. So, let's see, where's the arrow? Part 1. Write it in logarithmic form. And you'll start to get the hang of it probably pretty quickly. I do have to go back to the last slide for just a second because I want to write down how it's read. All right, because if you read it, it's easier to do this. So, let me go back to that slide real quick. I forgot to write this for you. And you guys need to practice writing this down and saying it out loud. So, in order to read this, you're going to read it as log base b, log base b. That will help you go back here because that's our base of y equals x. Log base b of y equals x. Say it with me.
Log base b of y equals x.
All right, good. Wow, that was good. All in unison. All right, here we go. Number 1, 3 to the 4th equals 81. So if you know what your base is and you know how to say log base b and know how to say it and hear it, this might be easier for you. If I want to rewrite this in logarithmic form, then I have log. What's my base going to be? What's the base of this Equation. 3. So log base 3 of,
81.
all right, good, equals 4. Because a logarithm is my exponent. All right, good. Number 2. Try this one. When you have the answer, raise your hand and I'll come look at it. Log 2 to the 5th equals 32. And I keep saying that it's important to read. So think about it as 2 as your base. Log base. Good. Good. Awesome. All right, what'd you guys get?
Log base 2, 32 equals 5.
Beautiful. All right, so log base 2 of 5 of 32, you guys said, right? My bad. Equals 5, so equals my exponent. All right, one more. And use this to help you because we also need to remember some stuff for our exam review. What's 25 to the 1/2 equal? 5, because 1/2, this exponent, it means square root, and that you're going to see on your exam review again. So 25 to the 1/2 equals 5. All right, that would be given to you. I just wanted to use that as a review real quick. All right, now we need to write it in logarithmic form. It's written in exponential form. Write it in logarithmic form. And in a second, we're going to go the other way. So use these answers and look at your answer and then look at what we started with so that you can see how to go the other way. Go from logarithmic form to exponential. Oh, be careful there. Okay. Did you get it? John? All right, what did you guys get? Read it out loud to me.
Log base 25 of 5 equals 1/2.
All right, cool. Another example or move on?
We're good.
Sounds like you guys are gotten it. All right, cool. Next, part 2. Write it in exponential form. So I'm going to give it in logarithmic form. And you need to try to rewrite it in exponential form. Your answer should look like what we started with in the last slide. So log base 4 of 16 equals 2. And right now we're just rewriting it. Now, when you rewrote it, is it a true statement? What did you get?
1/3.
All right, good. So when you're writing it in exponential form, you know if you're wrong because if you did, I don't know, what, 2 to the 4th? Oh, that would be right. That one wouldn't be a good example. All right, but you would know. Not with this one. All right, so what did you guys get? 4 equals 16. All right, good. That one worked, so that wouldn't be a good one. All right, try this one. Log base 7 of 1/49 equals -2. Use your answer as review. What does a negative exponent do to a number? It sends it to the denominator. It makes it a fraction. Yeah, exactly. So, when you rewrote it, how did you rewrite it?
7
Equals
-2.
The negative.
1/49?
Yeah.
All right, good. And notice it sends it to the denominator. Questions? What if I would have put an x here and said solve for x? Could you have done that?
Yeah.
So if it's written in logarithmic form, you would write it in exponential form, and then we would have had 4 to the x, and we would have just had to ask ourselves, 4 to the what power gives me 16, and x would equal 2. All right, so that's our next phase. That's our next goal, is to solve for x. So I'll give you one similar to that, and then we're going to take it to the next level, and it'll be a little bit harder. This is similar, okay? But when it's in logarithmic form, you're going to want to try to write it in exponential form first. So practice saying this to yourself out loud. How would I read number 1?
Log base 2 of equals 3.
Good. Log base 2 of x equals 3. Use that to help you rewrite it in exponential form, and then solve for x. Yeah. Okay, so when I write it in exponential form, guys, what do I get?
2 cubed equals x.
All right, good, which means x equals
8.
8. All right, very good. Notice that was isolated, okay? Because we have a log of a number. It has to have a number with it. So let's look at this one. Number 2. Log base 3 of 2x plus 5. This is my one number right here. So it's log of this number equals 2. Just because it's a little bit more, don't let it throw you off. You think about it the same way. Right? So log base 3. Think about what your base is when you're rewriting it. Make sure you have the parentheses.
Oh, yeah, sorry.
And then this is your base. You know, the rest of it. 2. What did you know that? Terry? You got that? Josh? 2. It looks like the consensus is 2. Dylan? 2? Did you get it? All right. So, do I subtract 5 first?
No.
No, because it's the quantity of this. I can't separate it. All right. So what do I do first then? All right. So 3 squared equals.
2x plus 5.
All right. Good. And then I get.
2x plus 5.
Subtract 5. Divide by 2. Good. X equals 2. All right. Awesome. All right. Next one. I want you to look at this. And then I want you to look at number 3, and I want you to compare the 2 and be very careful, because this is the first time you've seen a problem like this. So log base 3 of 2x plus 5 equals 7. Log base 3 of 2x plus 5 equals 7. Compare number 3 to number 2 and note some of the differences. What's the difference between 2 and 3? There's no parentheses. So am I taking the log of this whole thing?
No.
No. What do I have to do first? Subtract 5. All right, good. So I have log base 3 of 2x equals 2. If I'm solving for x, do I divide by 2 next? What do I do? Good. I put it in exponential form. Awesome. So 3 to the equals?
2x.
All right, good. So I have 9 equals 2x. What's x equal?
9.
All right, good. X equals 9 over 2. You guys have any questions so far? All right. We're going to go into, you want a quiz now?
Yeah.
We're going to look at some rules next. So, I'm not going to tell you the rule right away. I want you guys to kind of see if you can figure it out yourself. All right? All right, so, look at this one. Log, that's log, base 7 of 7 to the 5th equals x. Now, it's written a little bit differently than what we've seen. Normally, 7 to the 5th, that would just be one number. But we don't want to write it as that number. We don't want to know what 7 to the 5th is. We don't care for this problem. So it's written in logarithmic form. What do you think? So far, when it's in logarithmic form and we're looking for x, what have we been doing? We've been putting it in exponential form. So how would I read this problem? Yep. No, what she said. Yep. Good. So Monica, say it one more time.
Log base 7 of 7 to the 5th.
All right, good. So log base 7. That means 7 is my base. What's my exponent?
7 to the
7 to the
5th. X.
x. Good, because a logarithm, this is my exponent, equals 7 to the 5th. So you go about it in the same way. Now the only way that these two things are going to be equal, if they have the same base, what's going to have to be true about their exponents? They're going to have to be equal. So x equals 5. So when is this going to happen? Notice right here, 7 and 7. This was the base of my log. This was the base for my exponent. When those two numbers were equal, x equaled 5. Okay, so do you have to go through and write it in logarithmic form? Or sorry, exponential form? No, you don't have to, but it's up to you. Do you want to memorize a rule? Now it's kind of easy to recognize that the bases are the same, right? Okay, so you can use the rule, or if you forget the rule, you can just write it in exponential form and solve it. So let's write that rule. This is one that you need to know if you choose to do it quickly. So we'll say log base A of A equals, whoops, we need A to the x equals x. And so if I color coordinate like I did before, then we have our bases are the same, okay, and x equals x. This answer equals our exponent. And that's just something to move you along a little faster if you want. Okay, so let's try another one. Notice it's going to look a little bit different though. Log base 2 of 4 equals x. Now let's say I want to try to do this using this rule. Alright, these two bases have to be the same. Are these two bases the same? No. But can I make them the same? Yes. Alright, so I have log base. Can I change the 2? Or am I going to change the 4? Alright, so I have log base 2. How can I rewrite this as base 2? Alright, 2 squared equals x. So now my two bases are the same. What does x equal? X equals 2. If you rewrote it in an exponential form, you would have got x equals 2 as well. Okay? And then we have one more. And this is one where I find people find, it's a little confusing. So pay very close attention and ask me questions if you have them. 5 to the log base 5 of 7 equals x. Now I see the word log there. Okay? Is this written in logarithmic form or is it written in exponential form? Exponential? Are you sure? It is. What is the exponent there?
5.
Yeah, exactly. Good. This is my exponent. 5 raised to this power equals x. So even though you see the log there, it's written in exponential form. You might want to make a note of that this is in exponential form. So I don't know a rule yet. Okay? If I want to write it in, what form should I try to write it in? If it's an exponential? I want to try to write it in logarithmic form. Alright, so do this along with me. What should my base be? Log base 5. Good. This is my base. Of x or that? Of x. Alright, good. Of x equals, alright, a logarithm is the exponent. So log base 5 of 7. And the only way, guys, that a log with the same base is going to be equal is if their numbers are the same. So log base 5 of x equals log base 5 of 7. The only way they're going to be equal is if x equals 7. Alright, good. So x equals 7. And then this is the last rule we're going to talk about, and then I'm going to give you guys some classwork to work on. Alright, so notice this base is the same. Notice this base is the same. And x equals the exponent right here. Okay, so here's our last rule. Help me write it. We'll say b for base. Of log, what should my base be here? What should I call it with variables? B, good. Of x, good, equals x. Awesome. So if these bases are equal, then the exponent has to equal what the log is. And that's your last rule. Okay? So I'm going to give you your homework assignment. It is going to be a handout. Okay. Now, are there any questions before we get started? It sounded like you guys were okay on this. Now you have a quiz in 2 days. So let's see. Friday. Actually, I think it's going to be Tuesday, and I'll update it later. Okay, update the board later, but.